If the high voltage circuit is disconnected like this, a long arc will form between the contact and the contact point, and the arc temperature can reach 8,000 degrees Celsius, causing the contact point to start melting, and the circuit unable to be completely disconnected. To solve this problem, engineers invented the sulfur hexafluoride circuit breaker. Let's see how it works. The upper part of the circuit breaker is connected to one end of the transmission line, the middle part is connected to the other end of the transmission line, and the lower part is connected to the controller of the circuit breaker through a mechanical device. Its upper part is made of copper. And the fixed lower part on the street is also made of copper, but it is hollow and can be moved to connect with the upper contact to complete the circuit. The issue is how the lower contact can move upwards. This is where the mechanical controller at the bottom comes into play. The controller has two springs underneath, already in a compressed state. There is a plunger system here, connected to a relay and firmly pressing against the latch. Near the circuit breaker, there are also some current transformers. When there is a problem in the circuit, the current in the transformers increases, and they send the abnormal situation to the relay. This is when the plunger of the relay extends outward, releasing the latch. At this point, the spring on the left will release its tension, then quickly pull down, connecting to the lever on the spring, which is connected to the small gear at this position, causing the shaft to rotate rapidly, with the shaft simultaneously connected to 3 circuit breakers. Take a closer look at the cylinder of this joint. It is actually filled with sulfur hexafluoride gas, which, when the shaft rotates, will move the lower contact downward, generating a very powerful arc when the upper and lower contacts disconnect as before. Due to the downward movement of the piston, the pressure of sulfur hexafluoride gas increases, causing sulfur hexafluoride to move upwards, completely extinguishing the arc between the 2 contact points. How does sulfur hexafluoride extinguish the arc? Sulfur hexafluoride is able to extinguish the arc because high temperatures cause it to ionize into negative ions, which prevent free electrons from moving and thus eliminate the arc. However, there is an issue. After the arc is extinguished, the temperature inside the circuit breaker decreases, and under certain pressure, sulfur hexafluoride will transform into a liquid. At this position, a heater is also needed to ensure that SF6 remains in a gaseous state. Of course, SF6 will also be consumed, so a pressure gauge is installed at the top of the circuit breaker to replenish the gas once the pressure drops. Additionally, for added safety measures, all these contacts need to be opened to achieve double security. Here is an issue. Suddenly disconnecting the high voltage transmission line will cause a current surge. Since transformers are usually connected behind the circuit breaker, the sudden return of a powerful current can lead to voltage instability, even damaging the transformer. So unless there is a major accident, high voltage transmission lines are generally not disconnected. So how do you reconnect the transmission line now? Let's go back to the circuit breaker. In fact, there is also a relay on the right side here, with a mechanical design identical to the one on the left. When the relay receives a signal from the control panel, the plunger of the relay triggers the latch, which, when released, under the action of the spring, will start the rotation of the gear above, pulling up the lever on the left and compressing the spring on the left. Causes piston of circuit breaker to move up, connecting entire transmission line. However, there's an issue, pressure of spring on right side already released, so how to reset it? Actually, it's simple, electric motor behind circuit breaker. When circuit breaker closes, electric motor will drive gears to rotate, resetting spring on right side.
Thank you for watching this video by Australian Control Engineering, ACE. If you found our project insightful and want to see more innovative solutions in SCADA and control systems, don't forget to like, subscribe, so you never miss an update from us. Share this video to help spread the word about sustainable engineering solutions. For more information, visit our website. Join us at ACE, where technology meets sustainability.